Hello dear friends, welcome to Net Classes CS and Paper 1. Dear friends, myself is JYOTI CHAUBEY and I am going to teach you data communication and computer network. Dear friends, on here Net Classes CS and Paper 1, we are completing the syllabus of NTA UGC Net Computer Science, and I have completed artificial intelligence lectures on our channel. You can check the playlist. There is complete concept and previous year question is available here, but the concepts are in Hindi language. If you need in English, then please comment in comment box. I will definitely provide you English lectures of same. Okay, concept only for concept. Previous year question, or if you need previous year question also in English language, then I will also provide, but please let me know. Please write in the comment box what do you need from Net Classes CS and Paper 1. Okay, now here is our syllabus that we have already completed 2 lectures of data communication and computer network in English language, in which we have completed component of data communication system, simplex, half duplex, duplex, modes of communication, analog and digital signals, noiseless and noisy channels, bandwidth, throughput and latency. Okay, now we will discuss digital and analog transmission in this lecture. Dear friends, I will complete all the lectures in English language also. Please support me and please do subscribe my channel. I need genuine subscribers and genuine learners who want to learn computer science, and I will definitely complete syllabus of NTA UGC Net Computer Science and Paper 1 all. But please give me some time. I'm continuously working on it, but it will take some time because syllabus is very vast and I'm trying to complete syllabus in Hindi and English, both the language, and all the previous year question of NTA UGC Net Computer Science. So it will take some time, but please support me. Please like the lectures. If you like it, then hit the like button. Please comment, share with your friends, and do subscribe and press the bell icon so that you can get notification on time. Okay, now come to the topic, digital and analog transmission. What is digital and analog transmission? Digital means binary, digital means 0 or 1. Okay, and analog is continuous. Till now we have already seen the simplified communication model in previous lecture and digital data transmission. Okay, now we will discuss digital data transmission. How digital data transmitted via mediums. Okay, each signal bit can be represented as signal element. Okay, this is signal element. A wave which is starting from here and going to this is a unit, signal element. Okay, this is another signal element, this is another signal element, which means that any signal coming to our medium, via our medium, is in which we can see that there are so many elements. Okay, a single bit is element, signal element. Each signal element takes some time to send. Of course, if there is something present in in medium, then it will take time to transmit or to go or to pass through the channel. Then each signal bit, single bit can be represented as signal element. Okay, single bit, every single bit is represented as a signal element. This is signal and this is single. Okay, this is single and this is signal. Each signal element takes some time to send. I already discussed. Bit rate, the number of bits that can be sent out per unit time. Bit rate, number of bits that can be sent per unit time. As we all know that a rate of anything, just like minute, second, how we are calculating in our mathematics. The number of bits, all the bits that can be sent out per unit time. This per unit time, it may be second, it may be minute, it may be hour. Okay, it may be millisecond. Then this may the unit. Then how we can calculate the bit rate? The number of bits that can be sent out per unit time is called bit rate. It may be of any unit but in same unit. Objective of transmission. Why we are using transmission? What is the objective of transmission? Objective of transmission is to maximize the data rate, bit rate. Okay, we have to observe that the data rate or bit rate, we want to maximize it, means we want to, the number of bits that can be sent out per unit time, it must be increased. We want to increase it and we want to maximize it. But number of bits that the system can transmit in a unit of the time, maximize. We want to maximize this data rate or bit rate. Objective, this is the objective of transmission, and we want to minimize the error rate. We will try to minimize the bit error rate, means there should be less error in between the data transmission and the data rate will increase. We want to increase it and minimize it, but as the data rate is increased, the bit rate is also increased. So it happens, but we want to increase our data rate in control bit error rate situation. There is not any transmission media in which there is 100% error free data rate. It is not possible. But objective of transmission is to minimize the bit error rate and maximize the data rate or bit rate. But it happens that the data rate increase along with bit rate increase. I will give an example. Okay, if you are taking a sack of grains, if you are buying a sack of rice or pulses or another any grain, then if you are checking a small amount of grain, if you are cleaning the grains in small amount, then you will get the small error, means small dirt, a small garbage. But when you check the whole sack of 25 kg, then you will get the more error. Okay, this is the example of, in order to achieve high data rate, low bit rate, we need to study the principle of data communication. So I am trying to explain you that if the bit rate, if the data rate increase, the bit rate with bit error rate will also increase, because if we are checking a small amount of grain, then you will observe that there is a little bit dirt. But as you check the complete, as you clean the complete sack of grains, then the error, the garbage will also increase, isn't it? So we can relate this example from this objective of transmission, so that you are able to remember or recall it, or relate it, how it is practically related to our daily life. As we are another example of objective of transmission, that it is our daily life example, that in dictation in school, as we were in school, and teacher was dictating 5 lines, then there you will observe that there are little bit mistakes or spelling mistakes in dictation. In 5 lines it may be 2 or 3 mistakes, but if teacher dictate you complete 2 pages, then the error rate will also increase. Okay, if teacher is dictating you only 5 lines, then the error rate is 2 or 3. But if you are dictated 2 or 3 pages by teacher, then you will observe that your error rate is increasing. Okay, so this is the example that in our daily life we are observing that as much as data we are using, then it will increase the rate of error. It is natural phenomena, it is obvious, but we want to correct all the sentences, we want to control our mistakes in dictation, we want to buy a fresh sack of grains, so that we will not get too much dirt or too much garbage. But it is natural that as the data rate will increase, the bit error rate will also increase. But our effort is to increase the data rate and decrease the error rate. Okay, it is clear. Objective of transmission, why transmission, and what is the objective of transmission? This is in this slide, you can see that. Now we will proceed in next point. In order to achieve high data rate with low bit error, this is our objective of transmission, data transmission. We need to study the principle of data communication. On this principle, this is very important principle, and on this principle the whole data communication subject is based. Do you understand? In order to achieve high data rate with low bit error rate, we need to study the principle of data communications. This is the only base on which we are studying, we are researching, we are working for data communication and transmission system. Now come to next point, data transmission, transmitter and receiver. As we know that there is a transmitter and there is a receiver. There is a transmitter, we can say that sender, and there is a receiver, and the message passed through transmission medium. Then how transmission medium work? Signal are just electromagnetic. Okay, signal are just electromagnetic. One minute, I'm trying to show you this properly. Transmission medium. Signal are just electromagnetic waves travel through transmission medium. Two types. What are the types of transmission medium? Guided and unguided. Unguided, you can see that guided medium and unguided medium. Guided medium is physically present. Twisted pair cable, coaxial cable, optical fiber. And unguided medium is wireless, air, water, vacuum. Okay, these are the mediums. Now denoted or expressed by function of time st. Okay, S stand for time, st, and function of frequency. This is transmission signals. Signals, you can say that signals denoted or expressed in function of time st or S for signal. Okay, and function of frequency. By these two type we can denote signals st or time, function of time, or function of frequency. Now we will discuss the mediums, guided medium and unguided medium. Transmission medium, how transmission medium work. Then we have to know that what is spectrum and bandwidth. Spectrum is what? Spectrum is range of frequency contained in the signal. Range, the range from where you can send the signal, the range of frequency contained in the signal. These are signals and these are the range. Now we can see that absolute bandwidth. Absolute bandwidth is what? Width of the signal spectrum. There are so many frequencies which have infinite bandwidth. You can see that there is infinite bandwidth. With the signal spectrum, there are so many frequencies which have infinite bandwidth. And effective bandwidth, what is effective bandwidth? The limited narrow band of frequencies containing most or max of the signal energy, which give the noise-free, noiseless transmission. Now you can see that this is infinite. Okay, infinite frequency, infinite bandwidth, and in this is also called absolute. In this we are traveling, our message or data is transmitted through this. This is dense, this is effective. This is the limited narrow band. This is the limited band. This is also signal. There is also signal, but there is also bandwidth, but there is the limited narrow band of frequencies containing most or max of the signal. Most of the signal travel through this dense narrow band, okay, which give the noise-free, noiseless transmission. Means this band is dedicated to particular service. Just like we can see that FM radio, FM 98.3, 98.2, 102 point something something something. These are frequencies. We can see that in radio we are using this. Then this is the effective frequency. If we will set our radio on this frequency, then we will get the clear voice, clear program broadcasting. But if your frequency is change from this through that portion, then you will see that there are so many noises and the voice is not too much clear. So this is the dedicated, this band is dedicated to a particular service or particular channel, so that the channel can pass radio frequency, so that the signal can pass through this narrow band without any noise or any disturbance. So we can say that the effective bandwidth is the limited narrow band of the frequency containing most or max of the signal energy, which give the noise-free, noiseless channel. So this is very important that we have to know the spectrum, range of frequency contained in the signal, and absolute bandwidth, width of the signal spectrum. There are so many frequencies which have infinite bandwidth, but absolute bandwidth is not useful. Useful is effective bandwidth, which narrow or limited band of frequency is dedicated to particular service or particular channel, okay. So now you can understand that what is spectrum and bandwidth. Now we will discuss that the analog and digital transmission. Analog and digital transmission are: analog is continuous and digital is discrete. You can see that it is continuous, so it is costly. Discrete is it may be continuous or discrete, okay. This is cheaper. Generally this is found discrete, not continuous, okay. Amplifier is used to boost the energy in the signal. In continuous, in analog signal, we will use amplifier to boost the energy or the signal, because in this continuous signal frequency may decrease or may weaken, okay. As it become weaker, then if it is started like that, but it come like that, then we need to apply an amplifier here, so we can boost the frequency again. And then we see that the signals again come in boosted manner, previously frequency according to previous or starting signal. How in starting portion the signal is transferred Just like that, the amplifier is boosted again and again energy of the signal. But amplifier can't boost the energy of data. Okay, it will only boost the energy of signal but not the data. Amplifier is used to boost the energy of the signal but not the data. The data present in the signal will not be boosted by the amplifier. Amplifier and data is not related. Only signal and data is related. Amplifier and data is not related. Carries only signals without effect or relation with the content or data. As I say that there is no relation in between data and amplifier. Amplifier only knows the signal. It is not related with data. There is no any concern with data. Amplifier also boosts the noise. Amplifier also boosts the noise. Voice will be no. Now we can see that amplifier also boosts the noise. If signal is boosted, then the noise along with the signal by default it will also be boosted. Amplifier also boosts the noises as well. So voice will be not too much affected by cascaded amplifier used. Cascaded means you can see here cascade. Okay, cascade means continuously use of amplifier. So voice will be not too much affected by cascaded amplifier use. Data remain intelligible. This is periodic, continuous. This is analog signal is periodic and infinite number of values in a range. There are so many ranges because it is continuous. If you see that any graph 0 to 1, 0 to -1, there are infinite numbers in between this. Okay, so infinite number of value in a range. This is a continuous. So we can see that there may be infinite values in a range. But in digital transmission we can see that it is discrete. It is not continuous, so it is discrete. It is cheaper because here we have to maintain the amplifiers and signal frequency, so it is so much costly. But discrete digital transmission is cheaper than analog. Repeaters are used. Here we will use the repeater, not the amplifier. Amplifier and analog, A and A, you can relate this. In analog, amplifier is used. In digital, repeaters are used. Okay, repeaters revive the signal, recover the pattern of ones and zeros, regenerate the signal and transmit the signal. Use of repeater, what is use? Repeater receives the signal, recovers the patterns of ones and zeros, regenerate the signal and retransmit the signal. Okay, these are the uses of repeaters. Less noise. In repeater there is less noise, less susceptible to noise, suffer from attenuation. It will suffer from attenuation, and pulses become rounded and smaller, leads to loss of information. Cascaded amplifier will introduce bit error. It is non-periodic and limited number of values. Okay, so limited number of values because this is discrete and this is 0 or 1. Here we will use 0 or 1, and it is cheaper. Repeaters are used. Repeater receive the signal, recover the pattern of ones and zeros, regenerate the signal and retransmit it. Less noise, less susceptible to noise, suffer from attenuation. Pulses become rounded and smaller, leads to loss of information. Cascaded amplifier will introduce the bit error. Non-periodic, limited number of values. Okay, so you can see that these are the differences. Now I will explain it. This point I am little bit doubtful about this point. Bit error, cascaded amplifiers. This point is from this, I think. Now we will see that the data encoding and decoding. Okay, data encoding and modulation technique. What is data encoding and modulation technique? Data encoding, the encoding in the case of quantization. Quantization is a lossless compression using either run length coding or arithmetic coding. Quantization is a compression technique of JPEG. As we know that JPEG images are compressed, so this is called quantization. The encoding in the case of quantization is a lossless compression using either run lengthy coding or arithmetic coding. Lossless compression is called quantization. As we know that in compression the quality may be decreased, so this here we are discussing the quantization, which is lossless compression. We will compress the data, but it will remain lossless. Encoding. What is encoding? Now you can see that arithmetic encoding. Arithmetic encoding means masses. You can see that this is the masses or coding. To encode a message in arithmetic coding, we first need to assign the probability of occurrence to each symbol. If we have m symbol in the alphabet, the probabilities are P1, P2, Pm, in which P1 plus P2 plus Pm is equal to 1. Now we can see that interval 0 and 1. And in encoding, arithmetic encoding, we need to encode a message in arithmetic coding, we first need to assign the probability of occurrence to each symbol. So as we all know that in probability the occurrence of all the final value become 1. Okay, addition, after addition you can see that P1 plus P2 plus dash 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 Pm is equal to 1.0. So to encode a message in arithmetic coding, we first need to assign the probability of occurrence to each symbol. If we have m symbol in the alphabet, the probabilities are P1, P2, Pm, in which P1 plus P2 plus PM is 1. This is only a concept. We don't have to go very much in very much depth according to NTA UGC NET syllabus. We have to only know that the if we have M symbol alphabet, the probabilities in which is 1. Okay, occurrence of its symbol, probability of occurrence of its symbol will be 1. This is arithmetic encoding. And in Huffman coding, encoding and decoding in Huffman coding, so you can see that here we are sending a message. This will be encoded here by coding table, and the final code become finalized here. And just opposite, here is the code, and the decoder decoded this, and we find the message. This is encoding and decoding, that if you are sending a message, the message in high level language, we are sending the message, the encoder encoded the message in 0 and 1, and the 0 and 1 decoded after processing, decoded, and after decoding we will find the same message as we have used from as in high level language. Okay, as we send the message, we receive the message in that form, but in between that the encoder is used and decoder is used. Encoder is encoding the whole high level language in zeros and 1, and the zeros and 1 is processed, and after processing the decoder is decoding the zeros and 1s in high level language. We also can we know that we can know that it as Huffman coding. This is also called Huffman coding. There are 6 steps: 1, 2, 3, 4, 5, 6. Okay. Now you can see that Manchester encoding for fast Ethernet implementation. Then what is Manchester encoding? Manchester encoding is fast Ethernet implementation at the physical layer, can be categorized as either 2-wire or 4-wire. The 2-wire implementation, fast Ethernet implementation, STP, shielded twisted pair. Okay, and the fiber optical cable, and the 4-wire is UTP, unshielded twisted pair cable. Okay, you can see here, this is in our syllabus, and you have to understand it very well. Fast Ethernet implementation, Manchester encoding. In Manchester encoding there is fast ether implementation, and fast ether implementation is categorized in 2 categories: 2-wire and 4-wire. 2-wire is known as divided in STP and fiber optical cable. STP is shielded twisted pair cable or 10 base TX, and fiber optical cable is 100 base FX. And 4-wire is UTP, unshielded twisted pair or 100 base TX. You can see that it is T4 because it is 4-wire, and it is FX, fiber optical cable, and it is TX. Okay, twisted pair cable. It is only X for 2 and 4 for 4. This is Manchester encoding fast Ethernet implementation. Now we will see that in our syllabus there is data encoding and modulation technique, broadband and baseband. In next lecture we will discuss the modulation techniques. Okay, now we have already finished the data encoding. Digital and analog transmission and data encoding is completed in this video, and in next video we will discuss modulation techniques, broadband and baseband transmission, multiplexing, transmission media, transmission. Okay, these topics are remaining for the next video. Now please share my lectures in your friends. Please hit the like button and please do subscribe. Dear friends, it will motivate me to work for my students, and I really want to help you in free of cost and in detailed manner, in completion, with completion. There is no any shortcut. I want to express you all the things, and I want to explain all the syllabus, the complete syllabus in front of you, but I need your help and support. Please do support me, and I will support you till your success, till your JRF. Okay, so थैंक यू वेरी मच. पढ़ते रहो और बढ़ते रहो. थैंक यू.